This is experiment 2, preparation of alkenes. Precisely, we'll be looking at the preparation of ethene gas through the dehydration of an alcohol, precisely ethanol. So in a nutshell, this experiment is all about removal of water from ethanol, that is dehydration, to produce ethene gas, C2H4, which is an alkene. All right. So the process is called dehydration, removal of water. Now, in this process, ethanol is heated with excess of sulfuric acid at a temperature of about 170 degrees Celsius. You don't really have to check up the temperature. All right, there is an observation that could be looked into, that is the formation of darker color in the reaction mixture. All right, that's a sign to tell you effervescence is occurring in the liquid. Now, ethanol is heated. The gas that is produced, which is ethene, is passed through a sodium hydroxide solution, 10% aqueous sodium hydroxide solution. This is to remove carbon 4 oxide and sulfur 4 oxide produced from side reactions. Right? The dehydration of ethanol doesn't just produce ethene and water being removed. There are some side reactions. So the essence of sodium hydroxide is to remove carbon 4 oxide and sulfur 4 oxide produced from side reactions. Now the ethene is collected over water by the displacement of water over an inverted test tube submerged in water at the little space just above the water level. And that is what we call the upward displacement. And this is due to its lighter density than water. Gases that are lighter than water in density are collected by upward displacement. All right. Now, the concentrated sulfuric acid serves as catalyst for the dehydration reaction. We will not be going into the reaction mechanism, okay? But this is typically the reaction, equation of reaction, as you can see here. So in this experiment, you're expected to introduce some given volume of ethanol, right? It has been stated in your manuals, in a given volume of round bottom flask. All right, and this is followed by introduction of a given volume of the sulfuric acid, which is going to serve as the catalyst for the dehydrogenation process. And once this is done, you have to introduce the sulfuric acid while shaking just slowly into the round bottom flask containing the given volume of ethanol. And that is followed by the addition of some sand. It's going to serve as our granules to help foster the generation of gas bubbles, that is the generation of the ethene gas. All right, it really does not have so much impact or significance, but then this is what it's going to do to help generate the ethene gas to bubble out from the system. Now, after doing this, you now have to assemble the apparatus just this way I've presented here. But definitely this apparatus or this assemblage could be improvised. So from what you can see, in order to report this particular practical much more in a better way, don't forget, in this practical, you have to show the title, the aim, apparatus, stroke reagents used, the equation of reaction, the result. The result is based on the observation you made. What was the observation you made when this reaction went into completion? So show the observation or write the observation you actually made. Then this is followed by 2 precautions. Then you draw your conclusion. That is how you're going to report this particular experiment. And get to know why some of these have been used, like the sodium hydroxide. Why do we have to add sand to the mixture? Why do we have to heat over a sand bath? I've said that because the sand bath provides a gentle and even heat transfer in the system, thereby allowing the process to proceed controllably.